Hello students, I am Nilanjana Sunyal, an online math tutor from India. Welcome you all to my channel NS Online Math Classes. Now, as I had said in my previous video session that we will be having 2 more sessions on factorials and factorial notation. Today is our second and the last session on factorials. And in our today's session, we will be solving 2 questions. The first question is on equation containing factorials. And the second question is proving of an identity. The identity contains the binomial coefficients. And as you know, the binomial coefficients contain factorials. So in that way, it is also related to factorials. Okay? So stay tuned till the end. I hope you will be benefiting by watching this video till the end. Okay? And without any further delay, let us start with today's session. Now the first question says, solve the equation 16 times n minus 1 factorial equal to 5n factorial plus n plus 1 factorial, where n belongs to the set of positive integers. So let's start with our answer. So 16 times n minus 1 factorial is equal to 5n factorial plus n plus 1 factorial. Okay? And as I have said before, that if you have different numbers, factorials, you have to express the larger number factorial in terms of the smaller numbers factorial. Between these n minus 1, n and n plus 1, n minus 1 is the smallest number. So we will be expressing the n factorial and n plus 1 factorial in terms of n minus 1 factorial. Okay? Always in case you have to solve an equation containing factorials and you don't have any denominator as such, then you express the other numbers factorials in terms of the smallest numbers factorial. Okay? So we keep 16 times n minus 1 as it is, n minus 1 factorial equal to, now 5 times n factorial can be written as 5 times n minus 1 factorial plus n plus 1 factorial is n plus 1 times n minus 1 factorial. Okay? And now you see the entire equation contains 3 terms, 1 term on the left hand side and 2 terms on the right hand side. And all these 3 terms contain the n minus 1 factorial. So we can divide this entire equation by n minus 1 factorial so that these will get cancelled. Okay? And we have the equation as 16 equal to 5n plus n plus 1 times n is n square plus n. Okay? And this is a quadratic equation involving n, so we have to bring all the terms on one side of the equal to sign and make the other side equal to 0. Okay? And 5n plus n is equal to 6n. So we can rewrite this as n square plus 6n minus 16 is equal to 0. Okay? And this can be factorized using the Middleton splitting method, or we can just do this n minus 2 and n plus 8 equal to 0. If you cannot do in one step, you can use the Middleton splitting method. I can write this, it will be n square plus 2n, not plus 2n, sorry, minus 2n plus 8n minus 16 equal to 0. Okay, and then you will be just grouping these two terms and these two terms. You come to this step. Okay, minus 2 times 8 is minus 16, and minus 2n plus 8n will be giving you plus 6n. Okay, so this is the factorized form, and from here we get the two values of n. They are n equal to 2 and or n equal to negative 8. And we are seeing that n belongs to the set of positive integers. So we cannot take this. Therefore, the answer for this equation is, or for this question is, n equals 2. Okay, this is the answer, n equals 2. And if we just try to check whether our answer is correct or not, let us check. 2 minus 1 is 1, 16 times 1 is 1. So the left hand side is equal to 16. And what is the, let me write over here, left hand side is equal to 16. What is the right hand side? 5 times 2 factorial is 2. 5 times 2 is 10. And plus 2 plus 1 is 3. 3 factorial is 3 times 2 times 1, that is 6. So 10 plus 6, which is equal to 16. So 16 and 16, left hand side is equal to 16, right hand side is also equal to 16. Therefore, we are seeing that n equal to 2 is indeed the solution for this equation or this question. Okay, so let us move on to the next question. Now the second question is proving of an identity. It says prove the binomial coefficient identity in Ck equal to n minus 1 Ck plus n minus 1 Ck minus 1. So let's start with our answer. Now, whenever you have to prove an identity, it may be a trigonometric identity. In this case, it is a binomial coefficient identity. Always start from the side which has more number of terms. In this case, we are seeing on the left hand side there is a single term, and on the right hand side of the equal to sign there are two terms. Therefore, we start from the right hand side. Okay, so the right hand side is equal to n minus 1 Ck plus n minus 1 Ck minus 1. And if we just rewrite these two terms in form of factorials, they become n minus 1 factorial over k factorial and n minus 1 minus k factorial for the first term, and for the second term it is n minus 1 factorial over k minus 1 factorial times n minus 1 minus k minus 1 factorial. Okay. Now we do a little bit of simplification. It is n minus 1 factorial, and for this there is no simplification to be done as such, but in place of n minus 1 minus k, I am just rearranging the terms and I am writing them as n minus k minus 1. Instead of n minus 1 minus k, I am writing n minus k minus 1 factorial. Okay. And this is n minus 1 factorial over k minus 1 factorial, and this one is in fact n minus 1, and if we open the parenthesis we get minus k plus 1. So these two will be getting cancelled and we will be having n minus k factorial. Okay. So I am writing this as n minus k factorial. Okay. Now we are seeing there are two terms getting added together and each of these terms contains some part in the numerator and some other part in the denominator. And we have to add them. Therefore, we have to get the common denominator. Okay. So what can be the common denominator? Now the step that I am writing is not an essential step. I am just writing in case there may be some students who cannot directly deal with k factorial n minus k minus 1 factorial and k minus 1 factorial and n minus k factorial. For them I am writing this step for the sake of explanation, as well as you may write this step as well, because if you think that you cannot handle this step directly, it is better to write this step and come to the answer instead of trying to handle this step directly and come up with some wrong answer or make some silly mistakes. Okay. So k factorial, between k and k minus 1, k is the larger number, so I am expressing k factorial in terms of k minus 1 factorial. And n minus k minus 1 and n minus k, so n minus k will be the larger number, therefore we keep the n minus k minus 1 as it is. Okay. Plus n minus 1 factorial over k minus 1 factorial and n minus k times n minus k minus 1 factorial. Okay. Now we have to get to the common denominator. So I'll be writing all the factors. Let me take the line, draw the line little lower. So it is, I take all the factors of the denominator, k times k minus 1 factorial. Over here we are having k minus 1 factorial and n minus k minus 1 factorial, and over here we are having one new factor, that is n minus k. So we write n minus k times n minus k minus 1 factorial. Okay. And what happens to the numerator? Numerator of the first term, it is n minus 1 factorial, but the denominator got changed to this form. Previously it was k times k minus 1 factorial times n minus k minus 1 factorial. So what all factors got added or multiplied to the denominator? See, k was there, k minus 1 factorial was there, n minus k minus 1 factorial was there. This is the term that has got multiplied. So since this is the factor that has got multiplied to the denominator, this should get multiplied to the numerator as well. So this is n minus k. We are done with the first term. Coming to the second term, it also contains this n minus 1 factorial. Now what is there in the denominator? K minus 1 factorial, k minus 1 factorial, n minus k, n minus k, n minus k minus 1 factorial, n minus k minus 1 factorial. This is the only factor that has got multiplied to this denominator. So we have to multiply k with the numerator as well. So this times k. Okay. If you think you can come to this step directly from here to here, I don't have any objection. But in case you think this is required, then you can write this. Okay? So now, I can join them. I can combine them. K times k minus 1 factorial, it will be k factorial. That's why I am saying that this breakup is not essential. But it may help you to decide what should get multiplied with the numerators and what should be the common denominator. Okay? If you can handle these directly, I have no objection. So the denominator will be k factorial times n minus k factorial. Okay? Because k times k minus 1 factorial is k factorial and n minus k times n minus k minus 1 factorial is n minus k factorial. Okay? Coming to the numerator, we are seeing that n minus 1 factorial is common, so I can take this as the common factor. And from the first term we have n minus k, and from the second term we have a plus k. These two will be getting cancelled and we will be having n times n minus 1 factorial, which is equal to n factorial over k factorial times n minus k factorial. And what is this equal to? This is nothing but nck, which is equal to the left hand side. See, the left hand side is nck. Okay? So we have come to the left hand side. This has been proved. Okay? So students, this brings us to the end of this session. We meet again very soon. Now we will be starting with the binomial expansion, where the power, that is n, belongs to the set of rational numbers. Okay? So thank you for watching this video till the end. Please like, share, subscribe and comment if you find this video helpful. So bye for now.